Hey there, so more angle introduction stuff today. Please take a look at this page and pause the video and complete it. When you're ready to go over the answers, unpause and I will go over them. All right, hopefully you're ready to go over the answers now. For each of these, I kind of use like a 90 degree or a 180 degree angle as my guideline. So I can add a straight line here. And what I've done is I've created this section to be a right angle, their bottom plus my purple line. So then that's going to be my strategy for each of these problems. So the question is, how much is this? Well, it's much closer to 90 degrees than it is to 0 degrees. Here's my 0 degrees. Here's my 90 degrees. So I'm going to say 70 degrees for this one. And that's going to be my strategy for each one of these problems. On number 2, it's closer to 0 degrees, so I'm going to say 30. On number 3, I know it's past 90 degrees. Here's my 90 degree mark, and it went past that, so 140. Number 4, 25 degrees. That's kind of similar to number 2. Number 5, it's going backwards, so here's my 0 degrees. Here's my 90 degrees. It's pretty close to the middle. So I'm going to say 50 degrees. The middle would be like right here, and that would be 45 degrees. Number 6, I'm going to say 155. If I were to make a straight line, so remember I have to like use the same angle that they're using. Here's my straight line, and here's 90 degrees. So it's pretty close, but I think it's a little bit closer to the 180 degrees than it is to the 90 degrees. So that's why I'm picking 155 degrees. 740 degrees, BAC, would be this angle right here. It's not tiny like 15 degrees. 10 is 120 degrees. 13, I got confused with the numbering for a second, but it's going down, that's why. All right, so I'm going across, sorry. 13 is 60 degrees. I kind of would rotate my iPad here if I need to, but here's my 90 degree angle, and it looks to me like it's above the halfway point, so that's why I'm saying 60 degrees. Now I'll go down like I was supposed to be doing. So 7, 8, and 9. So 7 we said was 40 degrees. 8, angle CAD. That looks like a 90 degree angle to me. And then BAD, that looks like a 130 to me. 90 degrees would be kind of like right there, and it's still a pretty big jump, so 130 degrees. All right, 10, 11, 12. We already did 10 is 120 degrees. 11, POQ. It's a little baby angle, 15 degrees. Oh, it made a triangle. Whoops. 40 degrees would be like half of a right angle. I don't think it's quite that big. And then 12 would be 105 degrees. All right, 13, 14, 15. 13 we already said was 60. 14, angle Y. So here would be my right angle coming from this line. Looks like just about halfway of that right angle. So S. And then for 15, angle Z, you could really choose like either of these to be the right angle. So there's my right angle. So this is my 90 degrees. This is my 0 degrees. It looks like it's beyond the halfway mark. Here would be like my 45 degree angle. It's more than that. So 75. All right, we're going to take some notes on this page. So this is just to make sure that we all have the exact same vocabulary for each of these different words. So if two angles share a common side, so what that might look like is here's A, here's O, here's C. That's angle 1. And then angle 2 uses the C and O again. And then it also has B. That's angle 2. So they share a common side of C. We call that adjacent angles. Adjacent means next to. All right. When two lines intersect, any two non-adjacent angles formed by those lines are called vertical angles. And I see they're going to want a second definition. So what this means is we have two lines that intersect. Kind of looks like this. And none of them are adjacent. So we have like angle 1 here and angle 2 here. They're not adjacent. They don't share a side. They just share the vertex in the middle. So those are called vertical angles. But of course, 3 and 4 would have the same relationship, just sideways. We don't call them horizontal angles. We still call them vertical angles. So these are a pair, and these are a pair of vertical angles. And the other definition that you could say is that they are vertically opposite. But most people don't say that. Most people just say vertical. So that's for the second blank in that line. Vertical angles have a special property that they are equal to each other. So whatever angle 1 is, whether it's 90 degrees, 40 degrees, whatever, is going to be the same measurement as angle 2. And we actually use, instead of an equal sign, we use this, which means congruent. So that means that they exist in different places in the world. 1 and 2, they're not overlapping, so we can't say that they're equal. They're not exactly the same, but their measurements are the same. If one is 40 degrees, the other is 40 degrees. And then angle 3 would be congruent to angle 4 for the same reason. They're vertical across from each other. All right, the next definition. This one is going to be perpendicular over and over and over again. Two lines are perpendicular if they intersect in one point, and any of the angles formed by the intersection of the lines add up to 90. Two segments or rays are perpendicular if the lines containing them are perpendicular lines. So perpendicular just means that it creates a 90-degree angle. So if you have something like this, where each of these little guys is a right angle, then those two lines are perpendicular because they create the right angle. And they could be lines, they could be rays, they could be segments. That's what they're getting at. Any of these are perpendicular. All right, so now we're going to play around with these definitions again. So adjacent angles, we already said they share a line. They are neighbors. There's one line that they both have. So, and it says the measurements of adjacent angles add. What that means. We have this angle here, which they've labeled angle B. So that's B. That's CAD or DAC, doesn't matter. We have this angle here, which they're calling A, and then together they make BAD, which is this angle C. So if angles are adjacent and they're right next to each other, we can say that whatever the measurement of angle A is, plus the measurement of angle B is going to be equal to the measurement of angle C. So for example, if you know that A is 12 and you know that B is 50, we can conclude that C must be 62 degrees, for example. Vertical angles, the definition is that they are across a vertex and they actually share both lines. So in this picture, C is our vertex. And if you look, they both have this purple line and they both have this red line. Angle B and angle A both have the same lines making them up. And we know that whatever angle A is has to be equal to angle B. So if they told us that angle A was 50 degrees, we could conclude that angle B must also be 50 degrees because they are vertical angles and they have to be congruent. And it might even be better if I use the congruent symbol in this. Doesn't matter too much, but that's really my point, is that their measurements are congruent. All right, a couple more definitions here. Last page of definitions. Angles on a line. These, if you look at the picture, you can kind of see what relationship they're getting at. They're getting at supplementary angles, which is a long word. Supplementary angles. Supplementary in the English language means that they complement, well, I'll save the word complement for complementary angles, but they go together. So a supplement would be like something extra that's added in to enhance it. So supplementary angles enhance each other. And we know that they add up to 180. So whatever angle A is in this picture, plus whatever angle B is in this picture, add up to 180 degrees. Angles on a point. So angles on a point, if you look at this like point A in the center here, and we have our three angles A, B, and C. If I highlight those one at a time, you're going to see that they form a familiar shape. And hopefully you're seeing that that shape's a circle. A circle is worth 360 degrees. So you could say that all of these must, oh, not 36, 360. All of these must add up to 360 degrees. Angle A plus angle B plus angle C have to add up to 360 degrees, which is always helpful if you know two of them and you're trying to find the last one. All right, then they just want us to repeat complementary and supplementary. Complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Missing words all over the place here. So in the diagrams, you can see how the complementary angles work. They make a right angle together, but you could take them apart to kind of look at them. And same thing with the supplementary angles. They have to add up to 180. They make a straight angle. We're going to be using the idea of complementary and supplementary on the next couple of pages. So on these pages, we're always going to be using algebra. That's going to be the expectation. And I'm going to model how to show work. I'm going to show you guys on problem 2. So I can see that here's a straight line. So if I know that this much is 90 degrees because of this little right angle symbol here, I know that the rest of it must also be 90 degrees because together those pink and greens have to add up to 180. All I care about though is the green. So I'm going to get rid of all of this stuff. This has to be 90 degrees. So the algebraic expression I can write is B plus 31 degrees equals 90. And I'm not even going to bother with the degree sign. I'll just put that in my final answer. Subtract 31 from both sides, and I get B equals 59 degrees. Here I do want a degree symbol in my answer because B is actually the name of an angle. It's worth 59 degrees. All right, and then I want to show one from the bottom as well. I'll show number 6. So these are going to be complementary as well, but one of them is worth a whole expression. So I'm going to say 3x plus 6 plus 48 is equal to 90 degrees. And I'm not putting the degree symbols in right now. I'm going to start by combining like terms. 3x plus 54 is 90 degrees. Subtract 54 from both sides, and I get 3x equals 36. Divide both sides by 3, and I get x equals 12. Now, the question is, do they want the value of x or do they want the value of the angle? Look at the instructions. Find the value of x. They do not want us to substitute it back in. X does not get a degree symbol there. X is not an angle. X is part of this expression that would give us the measure of an angle. If I were to substitute that in and solve for it, I would put a degree sign on my answer. But x itself doesn't have a degree sign because it's not the answer to an actual angle. It's just part of it. All right, go ahead and pause the video. Try the ones you're supposed to do on this page, and then unpause when you're ready to move on. All right, hopefully you're ready to move on. On the next page, everything is very similar. It looks like it's mostly complementary angles up until problem 16. So go ahead and do any of the ones from the top of the page that you're supposed to do. Pause the video, come back when you're ready to move on. All right, I'm going to be going over just one of these before we move on. I think I'll go over number 9 because that has 2 expressions in it. So because they have that red right angle symbol there, I can assume that this must also be a right angle because together they make the straight angle, this one right here. So I know that these are complementary. My equation will be 2x plus 9 equals 3x plus 1. And I'm going to subtract 2x from both sides. 9 equals x plus 1. Subtract 1 from both sides, and I get 8 equals x. Wow, I actually did that completely wrong. I'm having a meltdown. These angles are not equal to each other. They are supplementary. Scratch all of that. I do not want to start the video over. Sorry. I set them equal to each other by accident, but they're not equal. They add up to 90. So actually what I should have done is 2x plus 9 plus 3x plus 1 equals 90. That's the correct way to set it up. Sorry. You can pretend I was just testing you. I'm going to combine like terms. So 5x plus 10 equals 90. Subtract 10 from both sides. I get 5x equals 80. Divide both sides by 5. And here's the correct answer. X equals 16. Since x is not its own angle, there's not going to be a degree sign on that answer. Very sorry about me setting it up wrong the first time. All right. And then on a problem like 16, here's our new stuff. We are looking at a straight line this time, which means they add up to 180 instead of 90. So b plus 117 equals 180. Subtract 117 from both sides. We get b equals 63. Now this, find the measure of angle b. This is its own angle. So b equals 63 degrees. All right, let's look at the next page. All right, see what you could do on this page. Pause the video, come back when you're ready to go over some answers. All right, so I'll be showing you guys some of these. The ones up here, you just have to find the straight angle like this. And I can see that straight angle is going to be b plus 34. So b plus 34 equals 180. Subtract 34 from both sides, and you get b equals 146 degrees. It's its own angle, so it gets the degree sign. The ones at the bottom, here's my straight angle. So that's supplementary. They add up to 180. This guy plus this guy add up to 180. So I have x minus 22 plus 135 equals 180. I want to start by combining like terms. I have a negative 22 and a positive 135. So I'm going to subtract those real quick. It's hard to do mental math while I'm talking. 113 plus 113 equals 180. Subtract 113 from both sides, and you get x equals 67 Oh, not degrees, just regular old 67. Just the value of x. It's not an angle. All right, and these are all going to be similar, so go ahead and complete page 10. Thank you guys for watching.